Okay, now that we've done some revision on equivalent effective interest rates, we can continue to continuous compounding. Okay, now from previous examples, it has been shown that when the number of compounding periods for a fixed present value and for a fixed nominal interest rate are increased, then the computed future value increases. So if we keep the nominal interest rate fixed and the present value fixed, if we increase the number of compounding periods, then the future value will increase. So it is reasonable now to ask what happens if the number of compounding periods increase to such an extent that we can think of compounding as continuous. So let's have a look at the following example. Determine the future value of 1,000 rands invested for 1 year at 12% per annum when compounding is annual, monthly, daily, and hourly. Okay, let's start when compounding is annual. Okay, and my present value is 1,000 rand, so I can substitute that by 1,000. My interest rate is 12% per annum, and it's compounded annually, so that is why I've got a 1 there. And then my future value, the following. Okay, now in B, we can make it monthly. Again, I take 1,000 rands, and now I invest it at 12% per annum, compounded monthly. So I will take my 12% and divide it by the number of compounding periods, and I've got 12 months in a year. Okay, and we can see what we expected to happen did indeed happen, that the future value increased from A to B, and in this case it increased with 6 rands and 83 cents. Now if the compounding is daily, and we divide it by the number of days per year to get the effective daily interest rate, and we have 365 compounding periods per year. Okay, and again there's an increase in my future value from B to C. The increase is 64 cents. And now if we make it hourly, and how many hours do we have in a year? We take the 365 days and we multiply it by the number of hours per day. Okay, and again there's an increase. There's an increase from C to D, and the increase from C to D is an increase of 3 cents. Okay, so we can see that the future value is increasing, but the increase is slowing down. So it's reasonable to think that my future value might reach a limit. And this maximum limit can be derived theoretically. But for the purpose of this course, we will only make use of the result for the future value if compounding is continuous. And the formula for continuous compounding is then given by this expression here. You know what the future value is. You know what the present value is. This E is a mathematical constant. It's an irrational number. My J is my nominal interest rate per annum, and N is the number of yearly interest periods. Okay, so if we go back to our previous example, if the compounding was continuous, then our future value would be the 1,000 rands e to the J, which is 12%, and I've got one year, so I multiply it by a 1 there, and if I round it off to 2 decimals for the rands, we get exactly the same as what we got in D. So you can see that for continuous compounding, we reach the limit. Okay, now you can add this formula to your list of important formulas. We've got the future value for simple interest. We've got the future value for compound interest. And now we add also the future value for compound interest if compounding is continuous. Okay, so let's have a look at example 18. Find the present value of 500 rands invested at a nominal rate of 15% per annum for 1 year if compounding is continuous. Okay, so we have the following information. We have the future value, that's 500 rands. We have the nominal interest rate J, and that is 15% per annum. And now the compounding is continuous, CC, continuous compounding. And it is invested for 1 year. So my N is equal to 1. So we make use of the formula for continuous compounding. Okay, but we would actually like to find the present value, so we can write it like this. E to the minus J times N. And now we can do our substitution. The future value is 500 rands. My J is 15% and my N is 1 year. And that gives me a present value of 430 rands 35 cents. Okay, when we worked with compound interest, we also had a formula to find the equivalent effective interest rate. We would also like to find a formula for the equivalent effective annual interest rate when we are working with continuous compounding. So to get to that formula, we can actually write it like this. If I invest an amount, the present value, at an effective interest rate IP, and I invest it for a 1 year, then that should be the same as when I invest the same present value with continuous compounding. And for 1 year, so my N will just be a 1. So the present value will cancel out. And now I want to find the equivalent effective annual interest rate, so I can actually substitute my P also with a 1. So then I have okay, and we would like to solve for I1, the equivalent effective annual interest rate. So to get I1 on its own, I subtract a 1 on the left and therefore also on the right. Okay, and this is then the formula for the equivalent effective annual interest rate when compounding is continuous. So we can now use this to do example 19. An investor doubles her money when investing for 4 years if compounding is continuous. Find the nominal and the annual effective interest rate for the investment. So what is the information that we have here? We have that the future value is 2 times the present value because the money doubles. We know that the investment is for 4 years, so N is equal to 4 years. And we know that compounding is continuous, so we have to make use of continuous compounding formula. Okay, and we would like to find the nominal and the annual effective interest rate. So first of all, we would like to find J, the nominal interest rate, and we would like to find I1, the annual effective interest rate. Okay, so let's first find the value of J. We make use of the formula for continuous compounding, so the future value and we know that the future value is 2 times the present value. And we know that our N is 4, so I can write this as 4 times J. Now the present values will cancel out. And then we must make use of the following result. The result is that the ln of e to the x is equal to x. So if we take the ln on the right, then the ln of the e function, we will get 4 times j. And if we take the ln on the right, we also need to take it on the left, so it's the ln of 2. And now to solve for j, that will just be the ln of 2 divided by 4. And that gives us a nominal rate of 17.3286%. And this is then per annum. And it's important to add here that the compounding is continuous. So it's important to write compounded continuously. And now we would like to find the equivalent effective annual interest rate. So we would like to find I1. And we now make use of the formula for the equivalent effective annual interest rate when compounding is continuous. And we know that that is equal to e to the j minus 1. So I substitute the j that I got in the previous part of the question. Just note here that I wrote it here as a percentage, and in the formula I write it in decimal form. And this is then per annum effective, or per annum compounded annually. So we can also write it as per annum compounded annually. So if you take any amount, let's say 1,000 rands or any other amount, and you invest it at this 17% per annum compounded continuously, or you invest it at 18.9% per annum compounded annually, then your future value will be exactly the same. Okay, you should now be able to do the exercises at the back of chapter 1. The exercises on section 1.1 to 1.9, you can do numbers 16 to 19. So you should be able to do numbers 16 to 19.